Hello everyone, myself Suraj. Welcome to my YouTube channel. So in this video, I will introduce you to a web application which I have developed. This web application is for generating mineral indices map with ASTER L1T data. So this is designed using Streamlit for the front end, and the backend calculations are done with GEmap, which uses Google Earth Engine. So this is an open source project. You are welcome to check my GitHub repository. So if you go to my GitHub repository, I have written a detailed explanation regarding the working of the app. So this GEmap is a Python package for interactive visualization of geospatial data and analysis. So this uses Google Earth Engine. So if you go to the Google Earth Engine site, so you can see this is a planetary scale platform for Earth science data analysis. This is actually a cloud platform. So all the calculations are done in the cloud itself. And if you go to this link here, you will see that Google Earth Engine has its data catalog. You can see that NASA, they have taken this ASTER L1T radiance data from NASA. And there are also other data sets also, like if you check again, okay, this is regarding the description. If you see the data sets, you see there are different data sets available with Earth Engine, Landsat Sentinel, etc. Okay, so if you, I will be providing the link of this web application in the description box. So in this web application, I have done the pre-processing steps using this ASTER pre-processing library available in this GitHub repo. So in this repo, they have written the code for pre-processing of the ASTER imagery, like digital numbers to radiance and top of atmosphere reflectance, etc. They have also included some masking functions, but I have modified the water masking functions because it was not suitable. It was not working properly. So I have written the script for water masking, and there are other masking functions in this pre-processing module, like the cloud masking and snow masking, everything. And I have additionally written masking for vegetation and also some other functions for trimming the ASTER scenes, which I will explain later in the video. So here, if you see this, how this pre-processing works is it uses the image reducing functions of Earth Engine. So if you want to see what is image reducing, go to this site, and here you see when the user defines an area of interest for which he has to prepare this mineral indices map. So when user gives the area, so what this pre-processing step usually does is it filters the ASTER image collections pertaining to the area and outputs some set of ASTER images. For example, if there are 5 ASTER images corresponding to the area, so it produces a single image by calculating the median values or mean values at each pixel. So for example, if if there are any clouds present in this at any locations, so if you take the median of that one, then clouds will be automatically removed using this reducer functions. So there are mean, median, reducer functions, etc. So this is how it works. Even if clouds are present in the final output image, the cloud masking functions will automatically mask the clouds. Okay, so let us see how this application works. So here, if you see this mineral indices I have used, which is available from in this PDF. If you go to this PDF, you will see the mineral indices here. So common indices I have included in the application. And this one more thing, this indices can be calculated only for areas less than 800 square kilometer. So you have to provide the bounding coordinates accordingly. So if it is larger than 800 square kilometer, it will not work. So this is due to some restrictions with the cloud Google Cloud account I'm having. I'm using a free Google service account which has some limited resources available. So that is why I have put the area less than 800 square kilometer. So, and the final indices map mostly will be displayed as a white image. You have to download it and see it in any GIS software. I will explain that one also. So let's start experimenting with this. So if I give some bounding coordinates and press submit, okay, then this will be displayed here, area. So let us go with the default values now. The trim distance I will explain later, and then it will pre-process the image. Okay, pre-processing step is finished. And masking functions, if I give some value around 0.65, then whatever NDV values above 0.65, it will be masked. If you don't want to mask, you can enter 1. So if I press submit, so NDV mask, your values with more than 0.65 is masked. You can also see that water bodies were also already masked here and here. So, and if you select any indices, for example, ferric, now it is calculating the indices. Simply wait for that one. Once it is calculated, then you have to press the download button, which will appear here. Okay, it has been calculated. So it is as, displayed as a white image, but you have to download this one. Okay, downloads, and if you go to download folder, and if you view it in any GIS software like QGIS or RGS, and if you change the display properties, for example, I will set this masking areas as black. Now it is white, now it will become black. Okay, then you have to change the min max settings, mean plus standard deviation. Okay, then you can properly view the image here. So this is one in this which the app created. Then if you see in any other index, for example, in some of the bands there are some errors, like the ASTER scenes, there are some errors in the some of the bands, mostly the shortwave bands. So if we see some indices like Muscovite, so this one is calculated using all the default values above 50 NDVM as 0.65 like that. If there are any errors occurring while generating this one, you simply have to you have to clear this values in the box, and you have to press the clear cache button. Then only you have to rerun the application if any error occurs. Otherwise it is fine, you can go. Now if you see this one, Muscovite, I will remove this one now. So if you see, there are some lines appearing here in the Muscovite band. Here is one black line, and here there is a faint line here also. So this is what happens when there are some errors in the ASTER scene. Some of the bands are having errors. So in order to reduce this one, I have provided this trimming function here, which is here, trim distance. So before changing any values in the trim distance or the NDVA mask, you have to clear this box, clear the values in the box, and press clear cache. Clear cache means whatever memory, whatever already you have downloaded the image, that will be in the memory of the system present in the cloud. So you have to clear the cache of that system, not your local system. So this will clear the cache from the cloud. And now if you see, all the other things have disappeared. So if you increase to 1000 and press submit, by the way, all the things help is given here in the question mark symbol. If you hover over that, you will see what is the function of each button. So let's say if you put 1, it will not mask the vegetation. See, only the water is masked, vegetation is not masked. So now if I press the Muscovite, usually this image calculations, what it includes some number crunching, huge number crunching. So since it is my free Google Cloud Service account, so it might throw some errors like user memory limit exceeded. For example, if I see, I have taken a screenshot of that. If you see this one error, user memory limit exceeded. So this error comes sometimes due to the restrictions with the Google Cloud. So now if I download this Muscovite band, and this one is the latest one. So if I see this one now, okay, now earlier there was some black lines, now it has disappeared, but still there are some lines here in this lines. So what you have to do is you have to again rerun the application with another values. So before that you have to clear this box and press clear cache. Then you may increase this to 2000. Then again it will pre-process the images. Then press the NDVA masking. Now again if you go for Muscovite, so this one is the latest one. Well, you see, latest one is does not have any bands. All the bands, that dark bands have gone. So this is how you should experiment with the trim distance if at all any bands come in your output images. So this is all regarding the application. So one more thing, if any user limit memory exceeds, then you can also change the resolution of the image. You can make it as 35. Then that memory limit error may not disappear, and finally you can download the images. If any other type of error comes, simply refresh the app, press the refresh button, then it will work again. So this is regarding the application. So this is I may also change some of the features in the applications in the future. So this is all regarding the application. So thank you everyone. See you later with another video.